the biggest people in robotics are making cobots, which means it amplifies the number of humans that can work in those places. Physically able is shrinking,
Yeah.
but you're multiplying each person's force, right?
Yeah.
The robots are switching the technologies, and you have the other workforce that's coming in. So if you do that in the right way, I think the net impact is not going to be that much. So in the concept of defense, you need to provide technology that will protect people, right? Like one example was the bomb disposal thing, or other things are like surveillance, going into hostile territory and all that, So to me, robotics and weapons, no for me. So no targeting technologies. Weapons are called targeting technology because the moment you take out, the emotion behind, going for that, to me, like the stretch was the automatic, machine gun, right? That means you can kill more very quickly. Why is there nothing after the robot vacuum cleaner that's in everyone's house? Think about that, right? Well, because there's nothing else
We don't
that
care.
it can usefully do and reliably.
Yeah. Awesome. Aveek, thank you so much for being here with us today. We had a chance to meet at Takeoff Tokyo, and I just remember your energy. Like you were like super passionate. We went to the eat as well together, and I remember then maybe a couple of months after with Vanas, we decided to start the podcast. We were like, we need to have Aveek. Here we are. We'll be talking today about your journey, robotics, and a lot of other interesting topics for sure. Before we dive into it, Aveek, maybe tell us a little bit more about you, your background, and what led you to your journey here in Japan.
Sure. First of all, thank you for inviting me. It was definitely interesting to meet you guys, and yeah, I won't comment on the food. But it was a great experience, and yeah, I mean, frankly, it's been a very interesting journey so far. I was exposed to Japan when I was back in Silicon Valley, so I moved here from San Francisco. Um, I would say the beginning of 2022, end of 2021, somewhere around then, when the COVID shutdown was still in place, and they made some exceptions for people to come in. But personally, my background is in robotics. I've always wanted to do robotics from a very early age, and I did my mechanical engineering degree, of course, with some robotics projects from BITS Pilani, which is the Birla Institute of Technology and Sciences, one of the premier institutes in India. Nowadays, they're producing a lot of startups, and they've had a few unicorns. So pretty proud of that. And then I went to University of Pennsylvania to the GRASP lab. My advisor was Professor Vijay Kumar, who went on to become, Obama's advisor at the White House, scientific advisor, and is now the dean of engineering. So, great person, great influence on me. And then I joined SRI International. And SRI International, if for people who don't know, is a big think tank R&D organization in Silicon Valley. They've been there since the 40s.
Non-profit, right?
Yes, it's a nonprofit. They also had a East Coast arm that was for profit when I joined, but gradually got merged. So for all practical purposes, a nonprofit. But the model was always the same. You do contracted R&D mainly for the U.S. government, and essentially a lot of military spending. But you also got to work on commercial projects with the idea that if something becomes successful and can be made into a product, it becomes a venture. So it's spun out. So that's the model at SRI, contract R&D, hardcore solving problems that are 20 years out, and then applying that to some, regular commercial use cases. And coming to Japan, after my previous, I did one startup in Silicon Valley, and after that, I was coming to Japan for work. We had a big client here. I can talk about it. It's Obayashi Corporation. We worked with them on a robotics project, and I liked it. And I also kind of saw a niche for us for the kind of technology that we were working on. And I also found my business partner here during those interactions. He was
Japanese person?
yes, he's Ushiro-san, Manabu Ushiro. He was working for Sojitz, who was an investor in my previous startup, and that's how we met. And we used to get together, and he would be like, "We need to bring this technology to Japan." I'm like, "Sure," and and eventually things worked out. My wife came to visit, and she loved it. We were like, "Okay, let's do it." So here we are in Tokyo.
Awesome. Why robotics? Like you mentioned, very early age, you got interested. Like, what got you interested in robotics?
Well, to begin with, as a kid, I was, I would say some people are born that way. So I was like very much into engineering of all sorts, which meant taking apart everything in the house. It's not a great thing, but I would take apart things like I would date myself like VCRs and, all kinds of electronics equipments that showed signs of any problems. I would open them and try to fix them. uh, and my dad gave me like tools before I should have them, including a power drill and things like
How
that.
old were
So
you back then?
uh, my power drill was when I was 5 or 6 years old.
That's
um,
crazy. That
yeah,
sounds
I know.
dangerous.
Yes, but so yeah, I mean, I blew out the fuse, electricals in the house at random times because I hadn't even learned about, electricity properly, right? So all that aside,
Mm.
the moment came when I got these toys from Japan. This was even earlier when I was like, I don't know, 4 or 5 years old. That was basically this robot. I would put robot in quotes because it was literally a walking toy, a robot that would walk a little bit and then a window would open up from its chest and it would show the moon inside. So it was a space robot. So that had a impact on me. And when I went to college, I was lucky enough to be exposed to robotics projects because BITS Pilani at that time,
Mm.
they had just started a robotics lab, like one of the first few institutions in India working on robotics labs. Other schools had it too, but it was a great opportunity, and we went deep because one of the projects I worked on was actually writing a new textbook for robotics. So we had to go really deep while in college, and that basically meant that I was in it for life.
Nice. While doing a bit of research about you, I saw that Bits Pilani has like 1.47% acceptance rate. That's very low.
Yeah, it is, but it is low, but that's partially because of the fact that India has a very large population.
Mm,
So, and there are very few good technical schools. There's the IITs, the more famous ones, and then there's BITS Pilani has a few campuses. So, by definition,
right.
there's not enough good schools. So it is difficult to get in for that
Yeah,
reason.
competitions must be really, really high. Like, how did you? I mean, what allowed you to get accepted? I guess, like among all the competition.
So the interesting difference between the BITS Pilani model and the IITs is, for the IITs, the Indian Institute of Technology, IITs, they require a separate entrance exam. And that separate entrance exam has stuff that is more advanced than your school syllabus. So you have to study separately for that.
Mm,
But BITS was like, no, no. We are basically going to look at your school performance, normalize it because different regions have different grading schemes, and then when there were that was one of the elements, and later on they introduced the first scholastic aptitude test, the BITSAT, which was again based on average school syllabus for that level. So they were always following more of the American system, where
interesting.
it was more fair, because it's not about what you do in one exam where you have to learn and cram outside of school to succeed in and get in, right?
Yeah.
So so that's, I would say, it was the good thing, is because if you do well throughout school, you
Mm.
get into BITS Pilani, right? So
Yeah, yeah, yeah. Yeah, but again, like, it's pretty impressive you got in because again, like the percentage, the competition is super high. Basically,
yeah,
like I can
I
imagine the
think, yeah,
pressure.
competition definitely helps.
Yeah,
I mean, it could also do yeah, it can cause mental problems,
yeah,
but if you are able to deal
yeah,
with it, it's beneficial.
yeah. I mean, and you started being passionate about it very early, right? Like,
Right.
so that probably helps a lot to.
Yeah. Yeah, and among my batchmates, all from mechanical engineering, I would say that there's only 3 or 4 of us who stuck with hardcore
Yeah.
engineering fields.
Which aspect of robotics do you feel, and did you feel the most passionate about back then? Because you have the mechanical background, but
Yeah,
from what you worked on later on, it seems all very related to computer vision, which
right.
is more
Yeah,
software.
yeah,
So,
yeah.
yeah.
So the fundamental principles behind both computer vision and mechanics and dynamics is all is the mathematics that underlies all of these is quite common. The only difference is the sort of conventions, right? So, say in mechanical engineering and dynamics, you use maybe you like to assign say coordinate frames like the x-axis, y-axis in a certain way. In computer vision, you assign them in a different way. But at the end of the day, some of the math, the fundamental linear algebra or solving equations, all those things is fundamentally similar,
Mm.
and a lot of geometry. So basically, I love essentially geometry and solving for unknowns and applying and then being able to do stuff with it, right? So actually, I enjoyed both the designing hardware. I did actually get into the full CAD CAM stuff from mechanical engineering, and so I actually enjoyed creating stuff
Mm.
with my hands, as well as writing advanced programs to make those pieces of hardware do amazing things.
Yeah.
So robotics gives you the whole gamut of what one can achieve
Yeah.
when you have a physical machine interacting with the real world, right? So that's the
And the whole link between all those aspects is math, and you basically
yes,
fell in love with math, I guess,
yeah,
and the
yeah,
whole.
and software programming from a very early age. That's one thing I did not mention is I got into software programming competitions at a very early age. Even though I was a I became a mechanical engineer by degree, but I equally dabbled in both.
That's amazing, and I think it's not something that, like, I don't know, like, for when I was younger, loving math will sound crazy. Like, what allowed you to kind of fall in love with that entire realm? Like,
Um, I would say that I did not actually enjoy math at an early. No one does, right?
yeah.
Because the reason being that education system, at least in most parts of Asia, is you basically are you're not given any motivation for why you're learning stuff. So for me, I guess I was fortunate enough that things were not difficult for me to like just study and pass and do well in exams. It
Mm.
was like I could just do that, right? And a lot of Indians you will talk to, some people they'll say they're good at doing exams. So that was that. But only when I actually left and went to grad school in the US is when I discovered the joy of really understanding what's going on behind the scenes. And that Professor Vijay Kumar was one of the best teachers I've ever had. And when
Mm.
he taught, dynamics, I'd done some parts of it in college. I was like, oh my God, now I really understand. So that's when I started appreciating
All the
it.
pieces starts
Yeah,
connecting,
yeah, yeah.
and
So
you,
until grad school, I was just doing it because
yeah.
I could, right? So
I feel like it's for everything is like that, right? You have to go through the kind of the boring aspect of things, and once everything starts connecting, you start utilizing everything you learned along the journey,
yeah,
and
yeah, yeah. And if you
interesting.
end up in the right place at the right time, right? So
Yeah.
if I did not come for grad school to the US and did not have good, exposure to good teachers and all that,
Yeah.
that may have never happened, right? I would have said I'm going to make money on Wall Street, right? Which a lot of my, college friends did because I'll
Yeah.
be a quant on Wall Street, something like that.
Yeah, still math, right?
Yeah,
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 yeah, yeah.
yeah,
Makes sense.
yeah.
I mean, the US, because like overall, like Silicon Valley, you were just attracted by that whole aspect, or like why the
Nothing
US?
to do with Silicon Valley. It was all about better higher education. At that time, maybe even now, I think when it comes to like graduate studies, I don't think there's any country that is, even remotely can offer what the US has to offer in terms of graduate studies.
Mm,
I mean, there are pockets in Europe and other places, but it's difficult, right? It's smaller. There's not this vast system of
yeah.
you can go to any pretty much there's so many universities. That's why
Mm,
they don't have that many Americans reaching grad school, so there's a huge opening for outside like foreign students to come in. So
makes
that's
sense.
amazing, and that's what
Yeah.
I think that's the strength. I mean, to this
Multicultural.
day.
Yeah.
Yeah,
All those cultures as well, all those
that too,
aspirations,
but
and
just the fact that there's so much resources for
yeah.
people to get to that next level.
Yeah.
Because if you stop at without getting to grad school, you don't go deep enough, right? So
Makes
yeah,
sense.
yeah,
And then you got into SRI.
yeah,
So you graduate, you got into there, like, which is like an R&D setup, basically, like very
yes,
deep.
yeah.
Walk us through, like, what were you working on there? What
Mhm.
did you learn, and what did you learn that also allowed you to then become a founder?
Yeah, so when you do a PhD, whatever, any graduate degree in a field which is fairly technical, uh, which is not say theoretical physics or not stuff where you basically are doing stuff in your head, right, and you're solve, but stuff where you're more applied and you have to do experiments that are
Mm,
physical. Um, Up to a certain level, you do well in grad school, but those are still like in lab or in control setup demonstrations of the technology, right? You're not looking to make it work in the real world. So when we went to when we went to SRI, what I was told was like, this is applied R&D, but this has to work all the time. As in, like, this is, our research is funded by the government, and the tests that are done by soldiers in the field sometimes, and so you have no control. So when you deliver something, it has to work within the specs of whatever you deliver.
A high pressure environment. Or...
It was high pressure, but also superbly rewarding, because my first project was essentially off-road autonomous driving. So there was a defense program, and there I got to see some of the brightest minds, my older colleagues, creating some of the technologies that have become commonplace now, right? So this whole visual slam and obstacle avoidance, stereo cameras, there was nothing at that time. So SRI created the hardware, the software, everything, except we were using even analog cameras, right? There were digitizers and everything was different.
Yeah.
So, and then we moved on to, believe it or not, we're talking in the early 2000s. We moved on to like driver assistance technologies, which is what self-driving cars, eventually became. So
Like ADAS and...
ADAS, yeah, which is funny because my name, ADAS. So,
Yeah, yeah, yeah.
so we joked about it a lot, but yeah, advanced driver assistance systems, and we were working, partnering with the tier ones like Autoliv and Ford and Delphi. We were basically the company where we were putting cameras on cars and showing that we could do, lane keeping, driver assistance, urban ACC. And I was actually working on those things, the algorithms, the testing on road, off. And we had a huge campus, so it was amazing, right? Imagine getting into a gigantic SUV, because you had a rack of computers then, right?
Yeah.
Like a Lincoln Navigator, and I had just learned how to drive, right? It was amazing. And then doing collision tests where you did not actually hit but almost did.
Wow.
Yeah, all the things. I don't know if it was legal, but I'm sure since nothing happened, it was legal. But so essentially, so right away we started with self-driving, and guess what? The self-driving stuff, the automotive industry was not ready for it, and that didn't work out. We competed with Mobileye for stuff, but Mobileye could do things with one camera. We had to do...
Is that the one acquired by Intel? Yeah.
Yes. Yeah. That was that was the most famous company in that space. They were doing perception for cars, right?
Yeah.
For all those things that are needed to enable autonomy. Mobileye wasn't doing autonomy, but they were enabling the perception, the situational awareness of what's around you, right? The lane keeping and
Yeah.
cars coming to you and all. So we were working on the same exact thing, but we needed one more camera. We wanted to use stereo cameras because that was more redundant and like human beings, right? So you can get
Makes
depth from
sense.
it. But the car manufacturers were, kind of reluctant to pay for one more camera. It was a very different world then.
Yeah.
So
They don't see the value yet. They don't really
so we
get what you're trying.
offloaded that technology on the DARPA Urban Challenge. That was what defined the self-driving car, right? So we basically participated and went to the final
What's the
round.
DARPA challenge?
DARPA Urban Challenge, yeah, it was called DUC, the DARPA Urban Challenge. That's where Google's self-driving car came from. So the Stanford team was basically like taken over by Google,
Mm,
and they didn't even win it. It was won by Carnegie Mellon, but Carnegie Mellon is another place where they have produced the most amazing robotics technology, but none of them have had the Silicon Valley explosion, right?
right.
It had to be Stanford. And SRI, by the way, stands for Stanford Research Institute, but not officially anymore. But that was the history. SRI
Interesting.
used to be Stanford Research Institute, not anymore. It's SRI only. So that was the connection. So yeah, it was like testing self-driving cars, working on bomb disposal robots, augmented reality.
Bomb disposal robots.
Yes, the ones from Hurt Locker, the kinetic Talon.
Yeah.
Yeah, I programmed them to be fully autonomous in the sense that the robot would go to the bomb, the soldier would remotely defuse it, but then he would hit a button, and the robot would autonomously go back to base. It would follow the exact path autonomously, fully, and just using cameras again.
Yeah.
Um,
Do you think it helps in order to get like working products and like when you know the actual setup it's used in? Like,
yeah, definitely. In some ways, that process of collecting the requirements from the customer. That's one thing that you learn very well how to do when you work for government R&D, because the
Yeah.
government is kind of redundant in the sense they like a lot of paperwork. On the other hand, everything is spelled out, right? The performance requirements are spelled out like in pages and pages and pages. So you can check off on that. So that prepares you in some ways for a product where you listen to the client and you capture that and you kind of deliver, right?
Yeah.
Rather than doing this ad hoc thing where, you know, like, you know, like Apple has their own vision of what things should be,
Yeah.
but it's never based upon like, asking the end user and then, you know, so, but that's how we did it always, right? The end user was the government, and we built things to spec.
Yeah.
Of course, the budget was huge, which
Yeah.
it can't be. So the budget aspect was never a problem, right? On those, the difference between
Mm.
government and commercial is that, right?
Yeah, yeah, yeah. I mean, same happens. Like we had several guests from the space industry on the
Oh, space is
channel,
even more expensive.
and
Yeah.
but it's the same principle, right? Where it's like because the government, because you start thinking about things differently, and like that's really interesting. So you worked on those amazing products, and I can see how you fall in love with computer vision from there, right? Because
Yeah.
all those applications don't happen without computer vision,
Right. And
basically.
actually, the most interesting thing for my PhD was I happened to be in a lab that was extremely famous for computer vision. So the
Right.
GRASP lab. So basically, some of the biggest names in the field currently all were graduate students there at some point.
Yeah.
So there was a huge focus always on computer. Actually, my thesis was vision-based navigation. So basically, for teams of robots. So it was not only one robot; it was teams of robots, and they were all using cameras as the primary sensor. So I was always into vision-based navigation. So I did the control theory part, which was the planning and control of the robot, like how to move it exactly.
Mm,
But without having perception, it's useless. So I didn't want to specialize in one side of it. I wanted to close the loop
that makes
completely.
sense. Yeah, that makes sense.
Yeah.
Do you how to say like you've seen computer vision evolving so much in the past more than 20 years now,
Yeah.
right? When you started, could you imagine how far we will get? Like, was that something that you could see happening, or you're like, no, this we will never get to the level of? Because I think the accuracy now is like insane, right? Like, did you
Yeah.
see it that way? Did you also
Hmm.
understand back then that it will be all about deep learning, machine learning, and all this stuff?
Yeah. So there's two ways to answer that question. So um, from a hardware standpoint, I believed it would happen because even in my limited time from grad school to SRI, like when I was at the self-driving car thing, I saw basically there was no hardware, and suddenly people had created dedicated chips, computer vision chips, to do real time processing, right? And that kept evolving, where first it was like this giant PCI card that would fit into your PC,
Mm,
to a computer that could be this size, and then it shrunk. So that was happening so rapidly that I was convinced that from a hardware standpoint it will happen. So our goal was to basically keep optimizing our algorithm so we can shrink into the smaller footprint. Of course, with the advent of AI now, we have gone again the other way, right? Now, again, it's bloating up the other direction. But from a computer vision standpoint, definitely I could see that the hardware would get more and more capable to achieve a lot. Now, in terms of deep learning, that was interesting because there was always a tussle between people who were doing deep learning. At that time, it was basically the only technology was neural networks. So there was a concept of convolutional neural networks, CNNs,
yeah.
and that was the other competing approach to all the image processing and chips that we were doing. And the godfather of that, Jan LeCun, came to give a talk. This I'm talking like almost, yeah, early 2000, late 9, yeah, early 2000, where he was the renegade and he had created this thing, convolutional neural networks, and he had actually programmed it on hardware. So he brought his demo to SRI, where he was giving a talk, and he showed us this, and we were like, "You're just, whatever you're doing with CNNs, we can do it in real time with our hardware too. So what's the big deal?" So that's how it all started. But of course, the other thing that happened was, people kept pushing that neural networks more and more and more, and what it helped solve was
Mm,
pattern recognition, right? So basically, being able to recognize things, and
yeah.
that's always been, Jan LeCun's thing, and moving on to what he's doing at Facebook at the fair, right? Facebook Meta,
Yeah.
fair labs, is I could see that there was definitely going to be applications for machine learning in recognition. Because if you think about it, right, the lower level vision that we have in our brain, the visual cortex, there's a primary, secondary,
Yeah.
and so on layers of visual cortex. Some of it is just simple geometric processing, right? That's where computer vision was, pushing along.
Yeah.
But after a certain point, you had to have more advanced a representation of
Yeah.
what you want to see and how you want to recognize that you saw that.
Yeah.
That's where deep learning obviously was going to, it was 100% obvious that it's going to solve that.
Yeah. So it's
So
inspired from how the human brain basically works.
exactly. So I had no doubts about it, that the deep learning would help, advance the other side of computer vision, right? The higher level reasoning sides of things. Um, so that was not a surprise. But what is most interesting to me was at that time, there was no way to actually understand how the human brain actually sees stuff, right? So that research where people started probing human brains and kind
Mm.
of figuring out, even like kind of reading what you're seeing, that was a surprise. And then moving on to things like neuromorphic computer vision, which means they're literally trying to map how the brain does computer vision to chips. And I know some people in ETH Zurich, and I met the team. That's super exciting, and I didn't think that that would happen so quickly.
Is
Uh,
that how like neural marketing works as well, where you can see like you see an image and some part of your brain gets triggered? Like is that the
yeah,
same
yeah.
kind
So
of
so
tech?
so that was a motivation for not motivation. I would say that gave the insight into understanding the pathways.
Yeah.
But now people are translating that to silicon, so actually
Wow.
building new. So that's what I'm saying. So that is happening now, and that's something that I don't think the startup, or not startup, the venture world has gotten onto this, but they should,
Mm.
because that means that it has to be super efficient, right?
Yeah. Yeah.
If the chip functions like a brain, it'll be super efficient. It's not going to be like hundreds of redundant computations. So
Mm.
it's even more than deep learning. It's actually neuromorphic,
Is
computer
that what
vision.
Neuralink is working on as well?
No,
It's,
Neuralink is actually brain machine interface.
okay.
It's
Different.
sort of related, but I'm talking about solving computer vision problems in a different
Yeah.
way, using different kind of architecture.
Yeah. Yeah.
And I said I just got exposed to it recently, right? So last year or something like that. And I happen to know the researchers. I met them at a conference, and I find it super super interesting.
It is super
They're doing
interesting. Yeah.
SLAM with neuromorphic, and I'm like, whoa, yeah.
What
Anyway, so
is yeah, I mean, I guess we can go a little bit more towards, your motivation to start your current company, Guide Robotics,
sure,
and which I guess it's all about SLAM
yeah.
and
Are
VSLAM.
going to ask me why it's called Guide Robotics?
Yeah, yeah, maybe not, but still we'll
Yeah,
do it
yeah,
anyway.
yeah, yeah.
But like, okay, so you started this company, Guide Robotics, about 3 years, no, 4 years ago now, roughly.
No, I would say we have to compensate for COVID. So I
Yeah.
would say I only moved here end of 2021.
Hmm.
So effectively, I would say a little less than 3 years.
Okay.
Yeah, just under 3 years
What was
for
the motivation behind starting that company? And but you started a company before that as well.
yeah.
So let's go through that, and then we go
Hmm.
to what's going
Yeah,
on right now. Yeah.
yeah. So this is an interesting segue to go back to what we talked about, right? So we talked about creating a technology or adapting a technology to a real world use case for Mobileye, right?
Yeah.
So the problem there was that there was no um, perception that was available for doing, autonomous driving on cars, right? Um, so with the robotics applications, it is somewhat different because due to for whatever reasons there are other sensors that work well in the
Mm.
robotics applications, like lidar, right, like laser based technology, which also helps with self-driving cars. But the idea is that if you wanted a compact and a cost effective stack that could give you the basic brain for a machine to be intelligent or do something meaningful, which means it's aware of its surroundings,
Mm.
and if it is asked to go from point A to point B, pick up something and drop it off somewhere, if I were to break down the field of robotics, it involves, just two tasks. One is go from point A to point B, and the other one is pick up something from something here and drop off something there. That's it.
Yeah.
Uh, I mean, you can, make it as fancy as you like, but that's it, right?
Yeah. Yeah. Yeah.
So, in order to do that, I had worked a lot on the underlying technologies, all the different pieces, right? Knowing how you're moving, knowing what's in your surrounding, what's in your path. Can you make that? Can you go this way? Can you go that way? What's the best way? Um, can I recover from problems? Can I, explore on it? So all those things together, if you can make it into this little package, you can democratize the whole thing, right? Instead of saying, that everybody needs to start from scratch and do something,
Yeah.
you just give that piece at a reasonable, cost. You license it. So that was the motivation for SRI to commercialize that technology, right? So we wanted to commercialize indoor, no GPS navigation for anything that moves, right?
Yeah.
And that was the previous company, our starting. It was called Area 17. We were doing drones.
Area 17.
Yeah,
Yeah.
so it was basically warehouse inventory counting. Now IKEA has this company called Verity, or forget, they have literally drones flying around and checking
Yeah.
inventory, right? But we were a bit early. The drone hardware wasn't, ready. But the idea was that how do you fly drones indoors
Is
without
that often
GPS?
the case, Aveek, where
Yeah,
the hardware is not ready yet, and that's where?
that happens often.
Yeah.
And there you separate the people that's a good separation of good versus, startups that are doing it for the wrong. If it's a good startup, like, some of the companies that have succeeded, they started early, but they basically decided to solve, all pieces of it, right? They're like, okay, there's no drone hardware, let's let's solve it. So
Mm.
they kept the team lean and they raised more money. So there's a couple of companies who survived and are doing it, but most others, basically did not make it. For us, it was a different story, but the end result for us was that we wanted to demonstrate that our visual navigation can solve anywhere where you cannot operate without a positioning, system, like without GPS, right? So we were flying the drone just using cameras, right? So basically,
So
just
that will
look.
be indoor applications,
Yes,
basically.
yeah, yeah. Most industrial applications are indoors,
Yeah.
and anywhere where there's GPS challenge, right? So if you're in greenhouses or places where there's, urban structures with tunnels, or anywhere where you just can't have GPS, right?
Yeah.
Uh, so that's pretty much it, right? So the domain is not just indoors, but GPS denied,
Yeah. Yeah. Yeah.
as in you cannot get a clear satellite, signal, pretty much. So the Area 17, it was drones, but while we were doing that, we were approached by this large company in the United States, Lineage Logistics, who recently went public. So they basically came to us and said, hey, drones are great, but can you put the brain of the drone onto our forklifts? We want to know what our forklifts are doing. I was like, that's interesting. And they were like, oh, by the way, the forklifts are in freezers. They have to go in and out of freezers. So that was a hardware challenge, right?
Mm.
Not necessarily what we wanted to solve, but again, that because we are from because I was from SRI, I said, okay, we'll try to solve it. But that helped,
Yeah.
creating a design that was, freezer proof, etc. And at the same
What's the
time,
challenge because it's in the freezer? Like,
so
what's the extra challenge
basically,
here?
yeah. So when you take a glass of when someone pours a glass of cold water, you observe that there's condensation outside, right? That's because the temperature difference and the humidity, relative humidity. So when you are in say, I would say, let's say 15 degrees Celsius, or 13 degrees Celsius, and you go into a room that's at 0 or below,
Mm.
when you come back out, the camera gets,
Ah.
so you need to have
Yeah.
heaters, basically. So
Yeah.
but how much heater, so anyway, so those
Interesting.
kind those
Yeah.
kinds of things. And remember, we were not making cameras, we were basically using off the shelf. So we had to, basically just encapsulate existing technology, but in a form factor that the client could use.
Yeah.
That's basically was the theme. And on top of that, then we had our Japanese client, Obayashi Corporation. They had an AGV system. They wanted to make it into a smart AGV system,
AGV standing for
autonomous
autonomous.
guided vehicle.
Yeah.
But in this case, AGV, the history of AGVs was they used to have magnetic strips on the floor, and the robot would just follow that, right? That's why it's called guided vehicle. Now, move on to now they're called AMRs, autonomous mobile robots, which means they don't need that guide on the floor. But, it's Japan, so they still called it an AGV, even though there was no. Anyway, so these AGVs for a construction site, and they wanted to make them autonomous, like smart. So they came to us and we developed the entire stack from scratch, basically. Not just positioning, but figuring out where to go, coordinating multiple robots and all of that. So that was the idea, right? That we would basically enable GPS denied navigation
Yeah.
for any industry that needed it. But VCs don't like platform plays, so that's why we wanted to, uh, when I did the next, uh,
Why they don't like it?
well, back in the day, I don't know if it is still the trend, but people often in Silicon Valley would try to say that, it's very difficult to do a platform play because you have to have so many different distribution channels and partners, and you have to
Right.
convince so many different industries. I mean, what they should be saying is that you have to have the right team to be able to do that, but instead they say that it's not attractive. So you should capture an entire vertical. If you're doing drones, do drones. If you're doing this, whatever. So we got some pushback there, but of
Makes
course,
sense.
yeah. So we had to we had to kind of pick between the forklift and the drones or something, right?
Yeah.
But luckily, we didn't have to pick because we folded shop.
If you can figure out the drones,
Yeah,
it sounds like easier to figure out the forklift, no? Because you're playing
true,
on.
completely. And in fact, one would even argue that it's probably better to do forklift than drones because drones are so complicated, right? They have
Yeah.
to
Yeah.
fly and
Exactly.
their
Yeah.
battery life is terrible. On a
Yeah.
forklift, you have unlimited power from the battery, right?
Yeah.
So yes, I completely agree. And as I said, but I was, as I said, I was a technical co-founder, so I wasn't like a big, I wasn't a big stakeholder. I had a chunk, but I wasn't like a equal partner kind of.
Yeah.
But the lessons learned, built we built the technology, had an amazing team. They all went on to like really great places.
What are the main lessons you learned from that
Um,
particular step?
yeah, so the main lessons were, of course, that while you may know a lot about the field, you learn a lot from people that you hire sometimes because they come from other companies like say Google or whatever, and you can learn a lot of good practices from them, right? It's a give and take, right? So it's not,
Right.
while you might have the domain expertise and the super deep knowledge on the technology, how to do development, like software development, like the modern practices, you can learn a lot from
So
people.
diversifying the backgrounds of
Yeah,
people.
yeah, definitely.
Interesting.
And also, if you find people that are not good, you should get rid of them early because that's finding one toxic person. Those are the big lessons, actually.
Yeah.
That don't just do interviews, also try to figure out personalities early
Hire
in
and
the hiring
fire
process. Yeah,
quickly
yeah,
and.
yeah, 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 yeah. Otherwise, the debt is terrible. Uh,
How do you know whether a person is toxic or not in that sense then?
that's
Because
a good question. Yeah,
yeah,
it's probably difficult, but one could be a deeper dive on references
okay,
and kind of telling people that I'm not recording this, I don't want it in writing, just tell me,
yeah,
um that
yeah.
that's the only way I can think of, right? I mean, how else would you
It's
figure it
funny
out?
because from a recruitment background, I see a lot of the startups that I help, they put very little effort on that aspect actually. Very little effort.
Until they suffer, they won't
Yeah.
know. Yeah,
I think it's often because there's a bottleneck on the technical skills, and if someone matches those skills, they're like, okay,
yeah, tech
worst
job.
case, we just put him in the corner there. He doesn't talk to too many people, so often are aware of those issues. And
Yeah,
this is another question I want to ask you as well.
yeah.
Based on that, was like, how would you look at it? Like, what's more important than the technical skills or the soft skills? Like when it comes to like very technical issues, like how would you determine? Okay, this person is fit for the team, or
um I would say for a technical issue, I don't need any soft skills. I don't mind clear communication, but there's a very easy line between being like focused and being like don't bother me and whatever,
hmm,
to going out of your way to be like basically almost like shouting at people and like telling them abusing,
hmm,
not like literally, but almost to the point of abusing, like throwing your weight around or saying things like that, right?
yeah,
And sometimes people do it in front of clients or so, so it can it can mushroom out of control very quickly.
too
And
much,
sometimes it could be a mental health issue, it could be something deeper, but you pay the price, right? So uh
yeah.
yeah, but yeah, I would say that just having the right temperament, right, knowing the situation and holding back is important. Doesn't matter, I mean, whether they can
Think first
give
and
right.
talk after. Like
Yeah,
make sure
yeah,
to
they just
think.
don't
Yeah,
do. Our policies do no harm, right?
yeah,
If you don't know or whatever, you're not feeling it, just don't go out of your way
yeah.
and inflict it on other people, right? So
Makes sense. Yeah, yeah. It must be tricky, like because engineers like not necessarily always have the best soft skills, and
Yeah, yeah.
but you need their creativity as well. So how do you get that out of people? It
Right, right,
seems like a
right, right.
challenge.
Well, yeah, I mean, it is definitely. But as I said, usually if it's something really out there,
Yeah,
then the reference check should catch it.
right.
I'm confident about that. If someone was really out there,
How do you get good references from people then as well? Because like you say, okay, you can say, okay, this is not recorded, this is
mm,
not this,
mm,
but often you might also ask references from actual competitors, for example, or people who might be
mm,
happy if you hired the wrong person. Like how do you
yeah,
actually get the
yeah,
best out of this? Yeah.
yeah, yeah. So I think, yeah, if you're lucky and if the person, depending on who they are,
Mm,
there are people who will only work for startups, right? As you know, certain employees, and there are people who have had a mix. I always prefer someone who has had a mix.
interesting.
So because if you haven't seen both sides,
Yeah.
I don't. There's no substitute for experience. No matter what anyone says, right? There's no substitute for experience or exposure.
Yeah.
Sorry, exposure and experience. Yeah, there's just no substitute.
True. Those people do sound more expensive though when they have the mixed background.
Well,
Often,
when you're a
right?
Silicon Valley startup, that's not a problem. So
Yeah.
we did not have Yeah, that I did not have any of those. The Japan problems don't
Yeah.
exist in Silicon Valley.
Yeah. Yeah. Yeah.
If you have, yeah, if you're a SRI spin out and you have, the right team,
Yeah.
yeah, raising enough money to hire proper people is not a problem, which is the good thing about Silicon Valley. That's one of the pluses.
That sounds great. Like you're not limited.
No, no,
That's
there's no
good.
excuses. Yeah.
And so then Area 17, then you decide to start Guide Robotics, come to Japan, we walk through the journey. Walk me through like what inspired you to start Guide Robotics in general, like being very focused, I guess, on Slam, V Slam, and
Yeah, so basically, I wanted to continue the work that we, did, and I saw the potential, right? Well, for the previous startup, and I went back to SRI in the middle, right? So I went back to SRI and continued working on those
mm,
projects. So I actually kept evolving the technology
interesting.
stack with the idea that we are going to spin out again. So this was always the plan between me and SRI. The idea was that, okay, for some reason this didn't work out, but we are convinced that we tasted it, right? It can work. So I went back, we kept evolving the technology, continued working with some of our clients like Lineage Logistics. We evolved it to the next iteration of the design. Even with Obayashi, we continued.
Mm,
But I was coming to Japan a lot, and as I said, I met my co-founder here, and together, he was saying that, look, this forklift application, it looks like a lot of people in Japan are actually thinking about what to do with the labor shortages, right? So they
yeah,
are, Japan has a problem with labor shortages, both in like skilled and unskilled, but skilled labor is difficult, right? Because forklift drivers are not paid much and they're older, they're retiring, and the young kids will don't want to
don't want
drive
to do it.
forklifts. Um, and it's a specific kind of skill, right? It's not this as like you could drive a car, but you can't just go and start driving a forklift. It takes a lot of training and you have to be licensed. So the problem that companies were facing was that it was difficult for them to find forklift drivers, and the ones that they have once they retire, there's no difficult to find replacements,
Mm,
and also they had no idea how many forklifts they should have. Like literally, there was no visibility. People talk about DX, right?
right.
Digitalization. How do you look into DX in current warehouses? There are just forklifts and pallet jacks. How do you know what's going on? The WMS systems are static, where you only see something being scanned. You have no idea what happened,
Hmm.
right? The truck came in and the stuff is somewhere, and then magically all the stuff comes back, and hopefully you didn't lose anything, right? But losses happen. So basically, Japan, being a technology hungry nation, they wanted to solve it. So they went after people trying to solve it with radio frequency based tools such as Bluetooth or ultra wideband, all kinds of basically radio based technology which can triangulate beacons and
Yeah,
tell you where things are.
RFID
Yeah,
and
yeah,
yeah,
yeah, yeah, yeah. Along those lines. So but that didn't work well because a warehouse is metal. It's a giant structure with metal everywhere, and also to scale those technologies, you have to put up antennas, right? To triangle, you have to put up base stations everywhere.
right.
So they tried, like companies like Nippon Express, who's now our partner. They were actually looking, and they were always trying to solve this. Like, how do you instrument and get observation into forklift operations or similar things that move around? And they had nothing. And that's where, we had already done this project with Lineage, and my business partner was like, look, Japan has enough warehouses, there's enough business here, we should do this. And I said, convince me. So we went through the motions, and did he did the research, we pulled the data, and it looked promising. And then we decided, but then COVID happened, so everything got like set back by like 6 months, right?
Mm.
But while we were stuck, we still managed to apply for this Tokyo Accelerator Program, ASAC, Tokyo ASAC. So we qualified, and then we did our pitch. We got some, help we got free, office space, which I couldn't enjoy until I got here. And we got an AWS award for our pitch. So we got AWS credits. So, things were moving along. But the only problem was we did a few POCs here and there, but we couldn't get the clients to open up because no one was allowed to go to warehouses at that time.
Right.
So,
Yeah.
um, yeah. But I was the point was that I was convinced that there was a need for this technology in this application. And of course, at the back of my head, I'm thinking, eventually this is just one application of the technology.
Yeah.
What we want it is for anyone who has any sort of a robotic application to use us. And what better country than Japan, right? Because for whatever reason, Japan has a lot of robots, and none of them seem to be able to do anything useful. Like, they're just, I don't mean the factory arms, they are the best, right, in Japan, but I mean the mobile robots, right? Most of them are just moving carts that are moving around aimlessly, right, doing nothing. So we wanted to basically guide people towards robotics the right way, right? Collect the data, show what the gaps are, right, by looking at forklift operations and seeing whether automation can fit into this warehouse, or do you need to start from scratch, right? Because not
Mm.
everyone can be like Amazon, right? Tear down the warehouse and build a new one that is built for robots or gantries,
Is
right?
that a challenge usually? Is like those warehouses are really old, it's old legacy, like, and that's why you cannot really implement the
Well,
newest
it's not
technology?
like people are building warehouses for robots. They're not.
Right.
People are just building warehouses.
Would it be easier to actually then start from there and just build an entire warehouse according to warehouse automation? Will it
Well,
be easier?
the problem is who comes up with this formula for a robotic warehouse. Like people like Prologis and GLP, like the people, DLP, I forget, I think DLP, yeah, the big warehouse people, they are constructing warehouses based on the space and racking and forklift operations. They are not going around asking robotics warehouse automation people, how should we build this warehouse so that we can put automation in there. But for us, yeah, knowing a new warehouse would be fine, but it doesn't matter, right? The whole
Yeah.
point is that the the big manually operated warehouses are not going anywhere for like 5 to 10 years, and we want to help people optimize their resources right now. But in the process, we are collecting data on what sort of paths and what sort of operations they are doing right now.
Yeah.
So we could do simulations with robotics companies and help them, saying that if you did this, you can show them that this would work better. So, we want to basically guide the robotics companies, guide our clients towards robotics. And also, if we have partners where they want us to take on the brain of the robot to make it do some, like, for example, nowadays there are automated forklifts, right? Automated guided forklifts, but they can only do like very scripted limited actions, right? They can't move from point A to point B very far. So if you partner with people like that, we could literally enable it to go far, right?
Yeah.
So
Yeah.
that's the the warehouse logistics operating forklifts, optimizing that is the current focus, because it's a that's a big enough business right now. uh, and I think that's where we will be for a few years, right? Basically examining the situation, giving analytics, and even if you want to
Mm.
have a uh, next generation of AI prescribing how warehouses should be built, where will you get the data, right?
Right. You need to
So
know where we are right now, and
exactly.
that makes sense. What are the current, like, there's quite a bit of companies out there in that space as well, right? Warehouse automation
Of
and
course, of course. And the biggest beef I have there is that what people have been doing is they have been developing the technology, right? The AMRs or whatever,
yeah.
right? Um, in some cases, they have tried to optimize the form factor to the client, but in most cases,
What's form factor?
a
So
form factor means the shape and size of the robot, what it can do,
right.
how much it can lift, and all that, right? But in most cases, what happens is people make standard production lines, right? They make a small robot, a medium robot, and a large robot. Small robot can carry this much, medium robot, like it's
Yeah.
like a checklist, right? and then those robots have requirements. To deploy those robots, you have to do this A, B, C, and you know what I'm saying. So it's not very simple for people to figure out
Hmm.
whether this is cost effective, is going to bring in the ROIs, and the robot maker cannot say anything because they have no observability about what their operating expenses are. Like
Right.
how, if they were to put a robot in there, how can they promise anything without knowing, what their
So
current
that's where
situation?
you guys come in, basically.
Exactly. So that's our hope, right? So we as we gather more data, we can help both sides basically.
Interesting. So you guys do benefit by those companies out there producing better hardware, producing better, but in the end, it will only get that good by being educated on what the current situation is,
Yeah.
and that's where Guide Robotics comes in.
Right. And I also want to, my view of how the robotics scenario is going to work in industrial operations is basically it is not going to be one size fits all. So we need to come up with a way. We want to be part of the solution, and we'll see how that works out. Where basically you essentially have the building blocks of
Mm,
how to make a robot that can do something, and based on the application, you put it together and deliver the application to the
yeah.
to the client. If you don't do that, it will not be prevalent everywhere because there's no one robot that can do every. There's no such thing.
Yeah, I mean, every warehouse is unique as well,
Every
and
application, like
yeah,
every
yeah,
application, right? Whether it's small electronics parts or this thing, and the unfortunate part of it is that in many cases people are just replacing manually pushed things with a robot, but it has no arms. So it's kind of like you know what I'm saying, right? It
yeah,
it, it is just it's hard to justify
yeah, makes
what you're going
sense.
to what you're going to recover from that.
Mm. What are the current, I guess, challenges for you guys that stop the growth right now? And like, are those companies like not interested in collaborating with you guys? Like, what are the issues that you're facing?
Yeah. So for us, I would say we are making, one of our strategic investors is this company called FCC, and they invested. It's public, knowledge. They invested in us, and they are also a client in the sense that they are using our consulting services and our Slam stack to provide robotics uh, solutions to their clients. So that might expand more in future. So we are making
Nice.
traction there for agriculture, for warehouse use cases and things like that. But yes, beyond that, it has been difficult to break into the OEM markets for forklifts.
Yeah,
That would be beneficial for us. So to partner with because then we can build it into we can literally do it into the forklift, right? And that would
that's at
save
the
us a lot
source.
of
Yeah.
cost, etc. Right? If the forklift comes with the hardware,
And
just
why is that a challenge? Like, they don't see the value. They want to build it themselves. Like,
I think just getting through to the right people is hard, right? People like Toyota. I mean, we are still trying. We are still having those conversations, but you know, the forklift is a refined product. It's like not
mm,
refined, mature product. So uh, on that side, it's difficult to find out who's even willing to change anything.
because it works as it is,
Exactly.
and
And then on the AGF side, it's usually the R&D arm of some manufacturer, and those people are KG, and they believe that they can do everything themselves, which is a classic problem with anyone starting out new in robotics, right? So
yeah,
um, there's a reason you use tools, whatever. So that's been one of the challenges on the forklift side of things.
interesting.
But other than that, the main challenge is just growing the team, and that's based on fundraising. So that's been a bit hard given that
Yeah.
all money is being sucked into AI
Mm,
right now. So it's kind of a
yeah.
difficult to do. Yeah.
Yeah, robotics is always that. Like, I mean, I only work with robotics companies mostly, and every time you just see the budget, like, as soon as there's hardware involved, there's like just a different story. Raising money is so hard. Like, we did talk a little bit about it off camera as well, but raising money is so hard here in Japan. Like, w- would it be easier for example, for you guys, like, to incorporate in the US, for example, raise money and have your first clients here in Japan, and then do the transition, have a Japanese office, for example,
Yeah,
like,
yeah.
would that be easier?
I don't know about easier or harder, but we definitely planned to do that, but we did not, because we had initial success with big names
Mm,
in the industry, and we were able to raise we didn't foresee it to do it right now, but definitely at the next bigger round. Right now we did a seed round, and we are doing a bridge kind of seed plus whatever round. So at this stage we don't need to do that, I think,
Okay.
but we definitely want to start the conversations with international investors for the next round, the Series A, because at that stage we would definitely do global, and it will be a question of the logistics and paperwork, but that can be handled, right? So
Makes sense. I guess, Avik, because I want to be, cautious of your time as well. I want to talk a little bit more about, as a CTO, as a founder, how do you deal with pressure of decision making? Because that seems like this is probably the number one skill that you have to master as well, right? Decision making, like pressure, like how do you deal with it? Would you say?
yeah, so I would say that engineering is all about decision making, right? Um, there's a pros and cons. So the mind of an engineer likes you know to make decisions, but it also likes to make decisions on concrete data or
Mm-hmm.
tangible things. So now therein lies the challenge, right? The fact that if it is something is not tangible, cannot be quantified, that makes it a slight problem. But for me personally, we learned doing this technique. It was called SWOT analysis: strength, weakness, opportunities, threat. So basically, you look at everything in that, you put it in four, one of these four categories, um, and that helps you decide, right? You rank it according to, like, is this a strength? Is this the weakness? Is it the opportunity? Is it a threat? And you look at where you are, and you decide whether which one wins, right?
Right.
Of course, weakness is bad, but I'm just saying. So yeah, so SWOT analysis is a good way as a strategy, and but there are still challenges when something is, as I said, something is not tangible.
Mm.
y- You have opportunity, which is the probability is not that high. That's where you that's where you have to use your gut, and that is where I said, exposure and experience. So
Yeah.
when you have been through that, it comes easier. And later on, you should always review and see whether it was a right decision or not. And as in terms of engineering principles, I always believe in a plan B and a plan C. you know
Yeah.
so I always have a plan B and a plan C. That's the other way I operate.
Mm.
Yeah.
I feel like especially in deep tech, right, where like you have to trust your guts and like, but and also you've been many times in a situation where you're a little bit too early, right?
Right.
So you know that like that other piece has to follow and like
Yeah, yeah. And also you have to internalize the fact that your client does not care about technology. That's the day one thing. Initially, as a grad student, you're all about
they just care
these
about
are,
a
yeah, at
solution.
SRI. They're like, okay, it's great technology, but it has to work. And then you migrate to the other side, where the client you meet doesn't care at all about what the technology is, computer vision, whatever. It doesn't matter.
Hmm.
Does it solve does it help me in the way that I want it to help me, right? That's all they care about.
Yeah.
And will that translate to my expected returns? That's it. So you have
And
to kind of
yeah,
get past
I
that.
guess the next challenge then is
Yeah.
like, can they see the same problem as the way you see it, right? Because even with the whole forklift
Yeah.
situations, like
Yeah.
if they could see it the same way as you do, it's like, there's not really a problem in the sense that things are working, but it's like the problem is it's not efficient.
Right.
And how that must be really hard to convince people like, hey, this is not efficient, but they're like, but it's working. So it's kind of like the same
Yeah.
issue
So
you're
I think, and
facing.
I think there, definitely working with industry so the Japan, the interesting thing is that there's a lot of these intermediate consultants who provide services. So those are the people who can take the data right now, and they basically break it down in a way where the client understands
Mm,
why or what is the problem. So we are learning from some of the, like, these retired gentlemen who used to be directors of, who are doing some of the analysis, because one of them is our advisor. And that's fascinating, actually,
interesting.
because they think in a very different way from, like, engineering statistics or anything like that. I mean, there's some commonality, but for example, they're correlating um, the the scans
Yeah.
from the WMS to see why was it that there were all these scans done in this place, but the forklift was somewhere else. Like, that means the driver just went somewhere and started scanning. Like,
Interesting.
So
Yeah.
those are the kinds of things that the warehouse people will care about. They're like, this makes no sense.
It's inefficient. Yeah. And
Yeah,
yeah.
plus he's not supposed to get down from the forklift and go somewhere else and start scanning, right?
Yeah.
That
Yeah.
doesn't make any sense.
Yeah. Pointing out the inefficiency and the lack, like the loss of kind of energy and like.
Yeah, and misplaced goods. I mean, this is like,
Yeah.
yeah. So in fact, when you go to these warehouses and you see, just observe what's going on, it looks like complete chaos.
Yeah.
You have no clue because you can't even see what their like what their marching orders are, where the forklift is going to pick out the pallet, because labels are tiny. I don't even know how they're doing it, right? How do they know where this thing is? Because they don't have drones flying around and telling them where things are, right?
Yeah, and like you said, then it makes it hard as well to replace if someone retires or whatever. It's hard to
Yeah, the
replace
knowledge is,
them,
yeah,
and
yeah,
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 that
yeah.
makes
They have
sense.
their ways.
What would, like, based on everything you've seen and done, like what kind of, I guess, advice would you give to yourself if you had to start over again right now, like, and you have to kind of save yourself a lot of time because, like you
Mm-hmm.
say, right, like the whole goal, I guess, for the next person is to learn from what you've seen,
Right,
learn
right,
from your mistakes.
right.
What kind of advice would you give if you
Yeah,
to yourself? Yeah.
I would say, first of all, you should be a little bit, take risks a little bit earlier, because I was like, I thought about doing entrepreneurship startups like theoretically a lot of times, uh, but I always thought the idea was not good enough or something. So of course, I'm not saying be like Silicon Valley, drop out of school and do whatever, right?
Mm,
But on the other hand, if you do sense or have a feeling that something is worth trying without compromising your basic conditions like throwing away your education and things like that, I would do it earlier. Take the risk, and also I would try to seek out people, the
mm,
right kind of mentors, and seek guidance early on,
makes sense.
because that comes naturally with age as you go. But if you can do
Yeah,
it early, you get
yeah.
a leg up because you're gaining the experience of these people.
But and I think you point, like you talk about the risk, like, but I feel like that's because I talk to a lot of people as well, and I feel like the way I perceive risk, for example, now in the current stage of my life, is very different. And maybe that's something that someone like you perceive risk in a whole different way. How would you help young entrepreneurs to perceive risk differently? Because I feel like that's often where the problem
Yeah,
lays.
so I think the best way to look at it is that it is way easier to take those kinds of risks earlier in life, because you don't have that many responsibilities. So if you don't make use of those 5-10 years,
Yeah,
it may not work out, but the point is it's the best time, right?
yeah. And
it,
you still
it
learn, right? Like
Yeah,
the concept of working out is
yeah,
is I mean, I'm sure among all your failures, you
yeah,
you still learn so much, and
yeah,
they still worked out, so to
yeah,
speak,
yeah,
right?
yeah, yeah.
Yeah, that's interesting. In terms of like exciting development in robotics and
Hmm.
what you see out there, like what are the next coming trends that you like? I mean, the whole Tesla robot came, all those things. There's so many cool
I
things.
don't want to comment on anything about Elon Musk's stuff, so
Okay.
except for SpaceX, which is amazing.
Yeah, yeah.
Yeah, yeah. But jokes aside, I mean, look, there are you will notice two kinds of commentaries in out there, right? You will
Mm,
have people who are the legends in robotics, like Rodney Brooks, or people like Brad Porter, who was the head of Amazon Robotics. What are they working on? They are working on robots with perfectly benign form factors. Like one is a big cart, one is sort of like a cart with maybe somehow, we don't know, it's secret. They're all collaborative robots, which means that they're literally things where there's a human, and at times it can become robotic, but at other times a human is, kind of guiding it. After spending their entire career on cutting edge robotics, right?
yeah,
These people are saying that this is the only kind of stuff that's ready today. We should listen to them, right? As opposed to the other side, who are raising hundreds of millions of dollars to make a humanoid that sometimes they say is for factories, where they show you a thing hobbling over and picking up a part and putting it in a bin in a BMW factory, or they're the creepy videos where you have someone that looks like, in like a stocking suit
yeah.
in the house, like hugging the owner or something like that. I'm like, this is like dystopian, like it makes no sense.
Mm.
They are not helping do any of the jobs that can be done today, like the dull, dirty, dangerous, right? Those are the three things for robotics.
We
D3.
had Michele on
Yeah,
the
D3 venture.
podcast.
Yeah,
Yeah,
yeah.
yeah, yeah.
Yeah. So that's what robots are supposed to do. And trust. The whole thing about Rodney Brooks, he always you know, there's a lot of things that he says that I don't necessarily agree with. But on the other hand, he's very practical when it comes to, you know, he was involved with iRobot too. I'm saying,
Yeah.
why is there nothing after the robot vacuum cleaner that's in everyone's house? Think about that, right?
Why? Why?
Well, because there's nothing else
We don't
that
care.
it can usefully do and
Yeah.
reliably.
Yeah, that's the thing. Like I see all those like just to go on the one
Yeah,
with Tesla and stuff,
yeah,
and I look at it, I'm like, it's so cool. It's so amazing to see
yeah,
the
yeah,
build up, but then
yeah,
it's like I don't want that in my house. I actually genuinely don't want it,
yeah.
and I feel like everyone feels the same way
Yeah,
about it, right?
and
Like,
why would you put humanoids in a factory? It's so complicated. If it falls down, it's like so many joints and degrees of freedom. As a robotics
yeah,
person, you optimize for the degrees of freedom to achieve with the least. You know what I'm saying?
yeah,
You
yeah,
optimize the least degrees of freedom and the battery use and payload. Like you have to do this analysis to come up with the best
yeah,
robot that fits the job. Not, but my take on this and this is that somehow. Uh, the the wealthy individuals in Silicon Valley have decided that they want to first replicate humans
yeah.
and then create AGI, which is which to people seeking God, right? So the idea is that we want it's
Mm,
innate in human nature, but they're going after that.
yeah. But maybe it's also it gives access to a wider market where the wider market gets more excited about robotics and eventually like
True, true. But do we
people
need to spend that much money on so many different companies?
probably not. Nah, probably not.
Yeah,
So your take will be that those more like simple robots that are able to collaborate with each other, that's really what's the
yeah,
exciting part
and
is.
I think unfortunately this ties into the whole military thing
Yeah,
where you will maybe you'll see these robotic dogs. All of this came out of military
yeah,
technology anyway. You'll see these robotic dogs and robotic humans marching against each other, right?
yeah.
Like basically having battle games or something like that. I mean, maybe entertainment. I mean, Disney has this amazing Spider-Man thing. Have you seen it?
I haven't seen
It's
it.
a humanoid Spider-Man. It does the flips and all of that.
Really?
Yeah.
What's your take on that? Because those are some controversial topics that I want to walk with to discuss with you about. But like the first one will be the impact of robotics on employment. Like
Hmm.
this is a big fear for a lot of people. Like what's your take on that? Because especially for someone like you who works like on this new tech, like you constantly push the boundaries
Hmm.
of tech. But how are you sometimes afraid of the impact that it will have on people?
So to give you a good example, so there are jobs um, that if they were actually replaced, like actually automated, um, would cause people's livelihoods, etc. However,
For example, like
for example, janitors, right?
yeah,
If you did have a janitor robot that was super effective, there'll be no janitors. But that's far away, right? But coming back to more realistic things, um, robots are supposed to do, as I said, dull, dangerous, and dirty, right?
hmm
Dirty, I said toilet clean anyway. Um, so things like excavators and those giant earth moving. So what I'm seeing now, the in between, what is happening is they are not replacing the jobs, but they're upskilling them in the sense the operator no longer needs to be in the cab
yeah,
of the excavator. So which means the newer generation of people who we know, I mean, if you have kids, they are only interested in video games. So harnessing that power by remote, I think that's where again another area that VCs should be like going, basically all in on, right? Solve the networking problems, right? The infrastructure so that remote operation becomes smooth. And then you have all these people in, who have these, amazing reflex skills
mm,
doing all this, using teleop, robotics, right?
yeah,
Even for farming, whatever, right? So
yeah, yeah,
but again, it's not it is replacing the dangerous part of the job, and the population is changing, right? You no longer have people who wants to wake up and climb into that thing and do. They don't actually want to do it, right?
yeah,
So in some ways, the workforce that's reducing, right? You also have this, the robots are switching the technologies, and you have the other workforce that's coming in. So if you do
mm,
that in the right way, I think the net impact is not going to be that much. It's not going to be as much as I know I don't like LLMs, but that LLM based AI stuff is going to eliminate, secretarial assistant.
Yeah.
Like that's like going to wipe out like the white collar jobs, right?
Yeah.
But this is quite different, I think, with robotics. And as I said, the biggest people in robotics are making cobots, which means it amplifies the number of humans that can work in those places or are physically able is shrinking,
Yeah.
but you're multiplying each person's force, right?
Yeah. 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 Like it's you see it more like I guess like an extension that keeps people safe, and but eventually like it will erase a lot of jobs and
So
but
I
yeah.
that's what I'm saying. So the time where it erases jobs is not here, and people have been talking about this in
How
10
about
or
the
20 years seconds.
self-driving trucks, for example, like which is one of the topics that often comes,
Yeah,
like
yeah. So
self-driving
self-driving
trucks.
trucks, they actually have a huge shortage of truck drivers in the countries where self-driving trucking technology is being introduced, and in the parts that they're being introduced. I actually know one of the investors of Kodiak. He's here in Japan. Do you know him, Justin?
No,
You should have him on. Justin Turcat.
please.
Yeah, yeah.
Yeah, absolutely.
So he's a friend. So they are literally going for those parts of the country where there is no one available to drive.
Right.
So this concept that no one is introducing this technology actually, and people won't. It's cheaper. Humans are cheaper.
Yeah.
So it's
Yeah.
like a no-brainer. So it's anyone who's saying it's erasing jobs. Robots are not.
Yeah.
AI, on the other hand, is different. But robots at the moment are not erasing jobs. They're literally, being called in to do more
Yeah.
that they can deliver right now, and they're failing, and then they're being kicked out, right? So that's what's
Makes
happening
sense.
a lot.
Yeah, and I guess a lot of the fear comes from AI and then kind of gets diluted towards
Yeah. So
robotics right
yeah,
now, right?
AI and robotics never liked each other until this whole humanoid thing happened, where they discovered that the humanoid problem is so hard, might as well give up and let's apply AI, right? Because it's going to solve the
Yeah.
physics. So
When it comes to the current, like the whole boom of AI, it still helps a lot, I guess, the evolution for robotics, right? Like maybe
I-
for simulation, for example.
um, simulation doesn't need AI, right? I mean, what AI? So by AI, I mean AI as a field, right? I mean that
Mm-hmm.
includes deep learning, everything. I'm not talking about LLMs. That's just one corner of AI, right?
Yeah.
What AI is going to help with is improving perception, as we talked about. So computer vision, yes, computer vision is hugely impacted. Okay, definitely. It will also help with higher level reasoning.
Yeah.
But if people think that is going to solve, the whole approach where people are just taking a camera and just doing stuff and it's going to, that doesn't scale. So this whole idea of a foundation model for robotics, good luck, right? Keep doing it, but you're wasting compute essentially because it's not
Mm,
essential. I mean, robotics is a very well, you could very structured.
yeah.
If you build a robot, you know exactly how. You know what I'm saying, right?
Yeah.
I'm
Yeah. Yeah.
sorry. So to me, there is a fit for AI, but it's being thrown.
Yeah.
Everything's being thrown aside, and it's basically being married,
Yeah.
directly.
I feel like this is one of the issues you're facing, right? When you're going to VCs and stuff, they
Right.
are a little bit too much on that whole AI thing. It's like they just don't see the way you see it. Where it's like, guys, we need to solve those simple problems first, and that
Yeah.
interaction between robots and that extension, like everything we just talked about.
Yeah, but they don't. But if they wanted to, they could just read
Yeah.
what the actual robotics experts are talking. I'm not talking about myself. I'm talking about people who are like well known, renowned.
Yeah.
They should read what they are saying. They should
Yeah.
read what the top AI people are saying. And if they still want to do something different based on
Mm,
what, say, the figure, figure or Tesla Optimus, if they want to believe that
yeah.
rather than what is going on, and just as I said, if they want to listen to only to the AI focused
Yeah.
founders, that's like by choice you're burying your head in the sand, right? That's my point.
Yeah.
Just look at it from all angles.
Yeah. 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 Yeah.
And I
That's
would love
yeah.
to have arguments with like debates
Yeah.
with anyone who wants to talk. I want to rationally, like, break it down.
One thing that we would want to do with the channel is actually starting debates and stuff as well, like
Yeah.
opposing people with
Yeah,
those.
yeah, yeah.
That would
Well,
be really
debating is a
interesting.
skill that's lost. We used to have it in school, right? I'm sure Europeans still know how to debate. Indians argue too much, but we argue, but anyway, still debate. In America, you can't have a debate now, right? It's like polarized. So yeah, it'll be great to
Yeah.
bring back debates, and especially in Japan, I think it'll be amazing.
Yeah, no, absolutely. Yeah, it's I did work for an English teaching school at some point, and I was teaching English for a few weeks literally, and the only thing I was doing was like putting students to debate. And
That's
it
the best
was,
way.
yeah, and they loved it, and it was really
It
interesting to
expands your
see.
mind, like to
Yeah,
see the other person. Because
yeah,
if you don't debate, you if you don't understand what they're saying, you cannot respond properly, right? So,
exactly.
yeah.
Yeah, that will be really interesting. Another topic as well is like the robotics in military applications. Like, what's your take on that, Avik?
Um, yeah. So robotics and military applications, as I said, my whole graduate school and SRI and everything was funded by DoD research, right? So fine, okay. Now, military, people have strong feelings about it, but to me, I, I would say we are somewhat, originally I'm from India, and right now we are in Japan, right? I think the similarity there is that we are from countries where I'm not talking about historically, I'm talking about at the present. I'm not talking about history. At present, where we are more of a thinking of military literally as defense, right?
Mm,
Which means you're going to defend. It's not like you're building something to go attack and target, right? So if you were to stick to that concept, right? I'm not saying the US is like that, but so in the concept of defense, you need to provide technology that will protect people, right? Like one example was the bomb disposal thing, or other things are like surveillance, going into hostile territory and all that. So all my work, and because for a long time I did not have the clearance needed, right?
mm.
So all my work has been in that area, right? I actively made a choice to not get, the what's it called? Whatever the classific, to get the top secret clearance, the secret
Yeah.
clearance. I made it an active choice to not get secret clearance because I did not want to work on targeting
What's
technologies.
secret clearance actually?
In the US, if you have secret clearance, you can work with weapon systems.
Okay.
So I chose, to me, robotics and weapons, no for me. So no targeting technologies. Weapons are called targeting technologies. So no targeting technology, because the moment you take out, you know, the emotion behind, going for that, to me, like the stretch was the automatic, machine gun, right? That means you can kill more very quickly, right?
Yeah.
Okay, that's automation, but still. So yes, so actively, I don't believe in that. I don't believe in targeting technologies at all.
Mm.
So, but defense, of any kind, protection, feel making your citizens safe, security, surveillance, all that,
Yeah.
up to a point, but not like police state. Like some countries are crazy
But
about
it's
that.
kind of hard to see the line, right? Because you
Yeah,
could build the robots like you say, the machine gun
yeah,
that is literally made to defend your country.
right.
But somehow you can, send it somewhere and like now it's an attacking
Yeah, but
device. And
that's only when you make it into a autonomous one, right? So that's my
yeah.
point. I would never agree to that,
So
right?
that's where the line is. Shall
Yeah,
not be
yeah,
autonomous.
yeah.
There's all shall always be a human with emotions behind the
Yes, yes.
interesting.
Yeah, someone, there's a justification for,
Yeah.
going for extreme force when everything else has failed.
So that's where the line shall be drawn. Like the automation for robotic systems shall be drawn there, where it's like it has the, I guess,
Not the automation, the autonomy.
autonomy. Yeah.
Yeah, the autonomous
Autonomy.
decision making. Yeah,
Yeah.
yeah, yeah, yeah. So yeah, I mean, that's my point. I personally don't want to touch, targeting systems, missiles, whatever. I mean, why do you need missiles, right? So you know what I'm saying? Like,
Yeah.
it's obviously a very different view from, but I think on average, no one really wants to go and attack,
Yeah. Must be
anything.
hard though, as like
Yeah.
because imagine like for example, you as an engineer, you build the best product out there, and
Mm,
suddenly the government comes to you
mm.
explaining that they want to acquire the whole technology, and they tell you what they're gonna use it for. What do you do?
Well,
Like,
this actually happened at UPenn. I don't know if you saw the news. There was a company called Ghost Robotics,
yeah,
where one of the professors was a co-founder or was part of the team. He's a famous professor, Professor Kodicek. So this was the spotlight dog, but that was the first one where one part of the military decided they're going to weaponize it. So they put giant. So and that was it. They sent out an open letter. The UPenn professor sent out an open letter like we don't approve of this, whatever. It didn't change anything, but that's how strongly.
they still took over the
Yeah, the company decided to move forward with it, but
yeah.
they parted ways. The academic
I mean, the
institution.
result still becomes the same, right?
Right, right.
Yeah.
Yeah. So I would,
So as an
personally dissociate
engineer,
myself.
do
Yeah,
you always
dissociate.
keep that in mind as an engineer that this
As I
this
said, I don't really work on anything except
yeah,
for that bomb disposal robot is also a SWAT robot.
yeah.
The same platform that was a bomb disposal is also called a swords platform. So you can outfit it in a different way where it is like a SWAT team, right? It goes and storms the base. but not
Wow.
autonomously. There's a remote control.
Yeah.
Yeah. So up to a point, but right now I'm so far from it that it
Yeah.
doesn't matter. But
Yeah.
when I had a choice, I was definitely actively avoiding.
Yeah.
Not
Yeah.
just me, a lot of our, the community actually.
Yeah, it's interesting. Like, I mean, don't want to go too deep into that because, like I say, we're trying to keep the time low. But
Yeah, no
like,
problem.
um, another question, and then we'll wrap it up, Avik. But like, a lot of a lot of engineers out there want to get into robotics and all this tech in general. Like, what kind of advice would you give them to get started? Like, someone who maybe has a computer science degree, kind of started purely on software, but wants to transition to robotics. Like, but most people then they can't get a job in robotics because they don't have that experience. How would you kind of approach it if you were them, like to transition into robotics?
Yeah. So I think the good news is that before it was true that just doing computer science, like no hardware, you couldn't. But right now, thanks to simulation, you being a very mature thing, you could have no other like mechanical electrical skills, but if you were very good with knowing the theoretical part of robotics,
Mm,
software part of it, and doing simulation, you would still be a valuable asset, right? So that's one way. But my personal feeling is that you should definitely do robotics activities like informal robotics clubs, or at least sign up for some courses where they do a little bit of lab work, and basically try to be interested in hands-on, like mechanically building stuff,
mm,
and looking at kits, like toy, so kind of tinker a little bit, right? But I don't think it's necessary anymore that you have to have you know worked on electrical or mechanical things
yeah.
in addition to just computer science. On the other
Mm,
hand, you could be someone who specializes in motor control, just motor control for something else, not even robots, and then you're still a valuable asset to a robotics team, right?
yeah. Yeah, from the recruitment perspective, it's really hard to find people now that are actually still really excited about hardware. Everyone wants to do software.
Yeah,
They
so
still
which
have a role, obviously,
right,
but
right, right.
like there's such a lack of hardware engineers.
Right. Yeah, it is quite difficult, but they do exist,
Yeah.
because if you think about the degrees, right? So there must be people graduating. It can't
Mm,
be everyone's graduating with computer science, right? That's not
right.
possible. So
Yeah.
yeah. So but being interdisciplinary is a huge plus. I think people should become interdisciplinary as early in life as possible. Like don't be interested in just one thing, right? One
Yeah.
subject.
So don't, yeah, like, I mean, that's the whole thing. Everyone, like a few years ago, was always, oh, you have to be a specialist in this and that. And I feel like now people should really go broader and broader.
For
Obviously,
robotics, you have to have a little bit of jack of all trades,
yeah,
little bit, just a little bit of tendency.
yeah.
Yeah,
I think the most valuable profiles out there so far that I see is like mechatronics people. Those will
mechatronics is, yeah,
always
that's
get
very
in.
rare, because yeah, even I don't know much about. I mean, I can do like consumer level. I can't do the circuit design and all of that, right? So
Yeah,
that mechatronics is definitely the glue which
yeah,
holds robotics together.
yeah.
Uh,
You'll probably hire, or you're already hiring right now. Like, what kind of people are you looking for right now?
that's
Avik,
a
so,
very good question.
yeah,
So uh, putting the fundraising thing aside,
yeah,
we are highly in need of people who can use open source like ROS based engineers, and I've gotten some leads from university labs, etc. Because I would evaluate them as interns first, because I've had good success with interns from as in they're still in the program, right? So
yeah,
they haven't graduated or something. But I'm also looking eventually, as I said, because we have our partners who want to do robotics but they are clueless, so they need help. So instead of me trying to spread myself thin and manage even the, because you know robotics, a lot of it is kind of like the plumbing is
yeah,
all done in this open source tools, and you can adapt the hardware and software to work on new platforms easily using those tools. And I need someone with that kind of experience, like with Ross,
yeah.
someone who has controlled a robot with Ross, right? I need those kinds of people.
Yeah.
I'm happy to start them as an intern, because
Interesting.
that I get to evaluate.
Yeah.
But and we might grow that team. And apart from that, just on the cloud side, we are we would definitely like to, depends on our model, but if we do want to grow the customer base that uses our cloud, we'll obviously need some backend
Yeah.
uh, someone to take on the back end full time.
It, like in terms of the tech stack on the back end, like is there a precise like language that you're looking for, or is like
Yeah, so that's a very this is a very sore spot actually, because what happened was, we I had a good guy, but he went on to, from he was contracting with us. He went on to join another startup in the US. But modern day backend developers use Golang,
mm-hmm,
and that's a difficult. What I found was it's difficult to find backend people who are not like JavaScript and all that, right? So our entire backend is written in Golang, and
interesting.
we tried to outsource that unsuccessfully. Um, but
Mm,
I, you know, the beautiful thing is with the LLM tools, I'm able to solve some of the problems myself. But that's not the point. The point is backend. We definitely need people with Golang skills, and I
Golang.
think
Yeah.
increasingly you will see people doing that. The reason being, Golang has the same kind of has similar performance to C, but on the server, on the backend side, because JavaScript, the performance is way faster
Yeah.
compared to the older technologies.
Yeah. Okay. Awesome. Final rapid fire questions with you, Aveek, and then we'll wrap it up. But if you were not in tech, and this, like I said, is a rapid fire question, so short answers. If you were not in tech, what would you be doing?
Art and photography.
Interesting. If you could give a robot one human trait, what would it be?
Subservience, submissive.
Yeah, good. Could avoid us a lot of issues.
That is a
Um,
definition of robot by Asimov. Yeah.
love it. Dream house for retirement. Describe it in a few
Oh, the
words.
Mediterranean coast.
Interesting.
Simple.
Favorite food in Japan?
Oh, that's hard.
Somehow that's a hard one.
Favorite food in Japan. Oh my god. Okay. Let's say yakiniku,
Oh, there we go. Same. That's always the answer I give as well.
and
Love
that's
it.
I only eat beef in Japan.
Interesting. The kindest thing someone has ever done for you.
Hmm. I mean, this is hard in a rapid fire because you
Yeah.
have to go through your brain anyway. But the point is, I would say that the kindest thing that anyone has done for me is basically, how my advisor would always put his students first, right? So he would basically go to these big events, talking, basically where you have to present stuff in front of, the heads of the Air Force Research Lab. Is that it's he could present the research himself, but no, he would put the student. He was like, you go. That builds your
Mm,
confidence. It gets rid of your jitters when you're speaking publicly and all of that. And also, he doesn't care if you screw up, right? That could cost the grant. He doesn't. He's just trusting you.
yeah. That's
So
important.
yeah. So
Putting
that
you in the
definitely shaped
spotlight.
the way he put always his students first up front. Shaped a lot of things to come, I would say.
Nice. Yeah. Best advice you have ever received.
Very easy. Um, Life is not fair. Deal with it.
Simple, true.
Yeah.
Love it.
Got it from a horrible boss, but it's okay.
I mean, that's
Great person,
resonates.
but horrible boss. I mean, in a management
Yeah.
sense, but great person.
Yeah.
So that's why.
Life is not fair. Suck it up. Love it. Avik, we could go on forever, but you're limited on time. So thank you so much for your time today. Hopefully we can have another episode at some point. As a token of appreciation as well, please keep our mug. We're pretty proud of our mugs. I want to give it to you. And yeah, thank you so much. It was awesome. Thank you.
Thank you. It was a pleasure, and I would like to see the bloopers. Thank
Yeah,
you.
absolutely.
Cheers.
Cheers, Avik. Thank
Thank
you.
you.